All right, guys. So today you're going to get out your foldable with the 4 different flaps on it. The one that we did yesterday with addition and subtraction equations. Today we're going to start with the multiplication one. So you're looking down here. And when a letter and a number are touching like they are here with 6 times x, that's a multiplication equation. So just like we talked about yesterday, we're going to do the inverse operation. So when an equation contains multiplication, like this one does, you're going to solve by dividing the same number from both sides of the equation. We want to get that x all by itself. Right now, the x is being multiplied by 6. So we want to divide by 6. And whatever we do to one side of the equation, we have to do to the other side of the equation. So on the left side, 6 divided by 6, these go away, and I'm just left with x equals 54 divided by 6 is 9. So x equals 9 is my answer. Now we're going to move on to the other flap. So when you see this, remember it's not a fraction. This is actually a division equation. So when an equation contains division, like this one here, we're going to solve by multiplying. That is our inverse operation, multiplying the same number from both sides of the equation. So here, this is being divided by 2. So to get that to go away, I want to multiply this whole thing by 2. And now my 2's go away. What I do to one side of the equation, I have to do to the other side of the equation. So I'm going to multiply the 4 by 2 also. These 2's went away, so now I only have x on this side equals 8. And that is our final answer. Now, you're going to look at this piece of note. We have 6 practice problems here. We're going to start with number 1. Remember, you can draw that line to separate your equation if that helps you. And we're going to circle the variable because we want to try to get the variable all by itself. The variable, this one is saying, it's a, and he's saying, I want to be all by myself. 2, go away. Well, how do we get a dividing by 2 to go away so the a can be by itself? We're going to do the opposite or inverse operation. And we're going to say multiply by 2. Multiply by 2. These 2's go away, which is what we wanted. We wanted the a to be by itself. 13 times 2, 26. But we like our variable to be in front, so we're going to say a equals 26 and circle our answer. Number 2, we can draw a line to separate each side of our equation if you'd like. We're trying to get the t by itself. And the t says, go away, 4. So what do we do to get a divided by 4 to go away? We're going to do the opposite or the inverse and multiply. Multiply by 4. So that goes away. And what we do to one side of the equation, we have to do to the other side of the equation. So I just have t here. T equals 7 times 4 is 28. 4 times 1 is 4 plus 2 is 6. So t equals 68. Let's look at number 3. You can divide your equation. We're trying to get W by itself. And we do that by getting the 13 to go away. How do we get the 13 to go away? Well, 13 is currently being multiplied by W. There's a little multiplication happening there. We want to do the opposite or the inverse of multiplication, so we're going to divide by 13. And what you do to one side, you have to do to the other side. These 13s go away, and we're left with W equals, and 39 divided by 13 is going to be 3. We don't love when the variable is on the other side, so we're going to put W over here equals 3 like that. That's the way we like to write it. All right. Number 4. So here, divide our equation. We want to get A all by itself, and right now it's being multiplied by 7. We want that to go away, so we're going to do the opposite or the inverse operation and divide by 7. What we do to one side of the equation, you have to do to the other side of the equation. Remember, the A is saying 7, go away, but then he has to tell him where to go. He's got to go to the other side. So we're going to take these 7s go away. We're just left with A equals 9. That is our final answer. Don't forget that you can check this all the time. If we go back up here to the top and we think about what we did, I'm going to erase this work for a second. So you had A, we're saying here that A equals 9, right? So right here I can put a 9 in for the A. What is 7 times 9? 63. So now we know that we did it right. We can go back and check ourselves if we would like to check ourselves as well. Number 5. So we're trying to get K by itself. Right now, K is being multiplied by 14. So we need to divide by 14 and divide by 14. That way we can get these 14s to go away. We're going to be left with K on this side. And 14 to go into 70. I don't know how many times. Let's guess. Do you think 5 times? Let's see. 4 times 5 is 20. And that works out really well. So 70 divided by 14 is going to be 5. Do we like our variable on the other side? Not really. It's not ideal. So we're going to flip it around, and there's our final answer. K equals 5. Remember, you want to put the variable there. You don't just want to say, my answer is 5. You want to say K equals 5. And then our last example is number 6. We're trying to get K by itself, and right now it's being divided by 9. So we need to multiply by 9 to get these 9s to go away. So K equals 3 times 9, which is 27. This is our final answer. And there you have it. So, multiplying and dividing equations are actually really similar to addition and subtraction equations that we did yesterday. We use the inverse operation to solve, and we always, whatever we do to one side of the equation, we have to do to the other side of the equation. All right? Y'all did such a great job yesterday, and I know you're going to do a great job with this today.